Thank you very much, Jock. So Deutsche Bahn may not be a well-known brand here in Australia, but they're the German rail network owner and operator. And through their strong rail strategy, they're aiming to increase passenger rail and freight rail volumes, as well as utilising 100% renewable energy as part of the overall decarbonisation strategy. A challenge to this strategy is that they still have over 3,000 diesel vehicles, which consume over 250 million litres of diesel per annum. That's a significant challenge that needs to be addressed to achieve the emissions reduction targets of 50% reduction by 2030 and achieving climate neutral operations by 2040. So a part of that strategy is transitioning to renewable electricity. So expectation is achieving that by 100% electricity utilisation for traction power by 2035. Currently, the high-speed rail services through Germany, so the intercity expresses, they're already supplied by 100% renewable energy. Increasing passenger rail, so replacing short-haul flights. Sorry, Stefan, but replacing short-haul flights with rail services to provide that zero-emission transport. But at the same time, it's expensive to extend rail networks, sort of from the existing network. So there's still spaces for short-haul flights and long-haul flights, and work being done for zero-emission flights is a step in the right direction. Deutsche Bahn Engineering and Consulting is the consultant to Deutsche Bahn Group, so we're helping to investigate and develop these technologies for Deutsche Bahn for implementation on their networks. So our research has indicated that electrification is not always possible. So even though we are switching to 100% renewables for routes that are sort of low traffic volumes, then it's not cost effective to electrify these networks. So we need to look at other technologies to replace the existing diesel operations. As part of this, we're also investigating the opportunities for hydrogen and alternative fuels, and renewable diesel, so HVO to replace fossil diesel consumption, as well as developing internal combustion engine technologies to utilise green fuels of hydrogen and ammonia. This is just a quick overview of the different technologies that are being considered. So, as I said, so there's electrification, battery technologies, hydrogen in the form of hydrogen fuel cells, and also the combustion technologies of renewable diesel, renewable fuels, hydrogen and ammonia. So as I said, so it's not always technically or sort of financially feasible to establish electrification, so provides the opportunity for other technologies of battery and hydrogen fuel cell. And these don't always need to be new purchase vehicles from OEMs. We have undertaken pilot projects to look at retrofitting of electric vehicles. So the traditional diesel electric locomotive lends itself well to a retrofittation with battery technology. But as Stefan has acknowledged, so approaching this with hydrogen fuel cell, you run into volume energy density challenges with hydrogen, and which also takes up passenger capacity on board. The hydrogen combustion technology. So that's a project that's in development at the moment, and we're at sort of the scale-up stage. So we've got a small test engine at the moment, which is undergoing trials and proving quite positive. So we're looking to scale up the engine. So part of that challenge was also a greenhouse gas are our NOx emissions. So they can be just as damaging to the carbon emissions and global warming as our CO2. So also specialised treatments for catalytic converters to as after treatment measures to control the NOx. So the other image on the screen there is one of our battery trains that is coming into service. So battery trains, so a passenger train is in the order of 120 tonnes. So it requires big battery, and so because we don't want to limit passenger capacity on board, then the range is limited. But at the same time, we can implement strategies to recharge the battery en route, so utilising overhead catenary. So we start to be able to optimise the cost approach to the technology, so balancing overhead electrification with battery technologies. So we did a feasibility study for a miner, and they had a route of 1,000 kilometres that they wanted to decarbonise. And the cost-effective approach was battery technology, but with 400 kilometres of overhead catenary. So, instead of spending in the order of, say, $1 billion for overhead electrification, that cost is now reduced by less than half. And the last project that we have in Germany at the moment, it's one of our flagship projects, and it's in participation with Siemens Mobility. So it's the H2GO's rail. This looks at the whole hydrogen ecosystem, so from green production, storage and refueling, as well as developing the rolling stock technologies, as well as special requirements for maintenance facilities of the rolling stock itself. So the production of green hydrogen is utilises the renewable energy that we put into our traction system. We also operate a high voltage three-phase transmission system to support electrification, and connected to that transmission system are wind farms and solar farms and thermal hydroelectric generation systems. So we're producing renewable energy, and we're using that renewable energy to produce hydrogen. So currently it's at a scale suitable for the H2GO's rail project. But as we transition from trial to operations, so we're currently looking at approximately 200 kilograms of hydrogen per day per train to operate between 700 and 1,000 kilometres. And but as we get more trains operating on hydrogen fuel cells, then that volume of hydrogen will exceed what's able to be produced economically in Germany. And that's it. Thank you very much.
Perfect.